In this video lecture, we will discuss the different types of control systems. Basically, there are two types of control systems: open loop control system and closed loop control system. This open loop control system is also known as non-feedback control system. So why it is known as non-feedback control system? Because we are not feeding the output back to the input. So that's why it is known as non-feedback. There is no feedback. There is no feedback from output side to the input side. And closed loop control system is known as feedback control system. So in that system, there will be a feedback from output side back to the input side. Firstly, we'll see what is a open loop control system. In open loop control system, as I told, there is no feedback from output side to the input side. As a result, this kind of systems cannot automatically correct the variation in the output. Or we can say that the output quantity has no effect on the input quantity. Why? Because we are not taking feedback from output to the input. See, if we are taking a portion of the output and feeding it back to the input, means we can control the output quantity. But here in open loop control system, which is a kind of non-feedback control system, there is no feedback from output side to the input side. So we can say that the output quantity has no effect on the input, and hence the automatic correction in the output is not possible. This is the block diagram representation. We have a controller and the controlled process. We are applying the input to the controller, and the output of the controller is applied to the controlled process, and from the controlled process we are getting the final output. So if you look at this diagram, we can see like there is no feedback in this system. So this is just an open loop system. For example, what we have discussed in the last video lecture, a temperature control system. You may be remembering the first diagram that we have discussed regarding the temperature control system. There we were just trying to change the temperature inside the electric furnace with the help of a relay circuit. So we are applying AC voltage to the relay circuit, and that is ultimately applied to the heating element in the electric furnace. So based on the voltage, the heating element will start to heat and the temperature in the furnace will start to increase. So if we want to change the temperature in the furnace, we had to switch off the supply, and that was to be done manually. But in that particular system, the problem is like we cannot maintain a constant temperature. We can vary the temperature in the electric furnace, we can change the temperature in the electric furnace, but it was not possible to maintain a constant temperature. Right. So if we want to maintain a constant temperature in the electric furnace, then we should go for a closed loop control system. We should give a feedback. So that was the second diagram we discussed in that section. With the help of a controller, we were actually generating an error signal based on the actual temperature inside the furnace and the desired temperature, and that error signal was actually fed back to the input side. control the relay circuit. So based on the error signal, the relay circuit will either switch on or switch off. So we didn't have to do it manually. So it was automatically done based on the error signal. So in that system, we have actually given a feedback. So it's a kind of closed loop control system. So here, if you look at this particular diagram, you can see that we have a controller and a controlled process. So we are not taking any kind of feedback from the output side to the input side. So this is open loop system. There are several advantages and disadvantages for these systems. The advantages of an open loop control system are they are simple, easier to construct, then they are somewhat stable systems. They are stable and they are actually cheap. Okay. But at the same time, these kind of systems have several disadvantages. Like, as there is no feedback, we cannot do any kind of automatic corrections. Okay. So as we cannot do the corrections in the output, the system is inaccurate or unreliable, we can say. So these are the disadvantages of a open loop control system. So no automatic correction in the output because there is no feedback. So since we cannot do any automatic correction, the output that we get may be inaccurate. If it's inaccurate, then definitely we cannot rely on this system. So it's unreliable. So these are the disadvantages. So now we will go through the closed loop control systems. As I told, these closed loop control systems are also known as feedback control systems. Why? Because we are taking a feedback from output side to the input side. So why we are giving such feedback? We are giving such feedback in order to correct the variations in the output. Okay. So in this type of systems, the output quantity will be having an effect on the input quantity, because we are taking a portion of the output and we are feeding it back to the input side. So definitely the output signal will be having an effect on the input quantity. Okay. So in this way we can maintain the output at a desired value. So such systems are known as closed loop control systems. See, if you look at this particular diagram, so like the previous diagram, here also we have a controller and say controlled process. Instead of a controlled process, we have a plant. Both are the same. But in addition to the open loop control system, here we have a feedback. So we are taking a portion of the output and through a feedback system we are applying that signal to the input side. So at the input side we have kept an error detector. Okay, so what the error detector will do is it will compare the reference input and the feedback signal. So based on the comparison, this error detector will generate an error signal, and that error signal is applied to the plant with the help of this controller in order to correct the output quantity. Okay. So for this system also there are several advantages and disadvantages. The advantages of this kind of system is that they are accurate, because we are doing the automatic corrections in the output. So accurate, they are less affected by noise, accurate even in the presence of non-linearities. So we can ensure accuracy even in the presence of some disturbances or non-linearities. Again, fourth one, the sensitivity of the systems may be adjusted to make the system more stable. Actually in this kind of closed loop systems, stability is actually a major problem, but to some extent we can make the system stable by adjusting the sensitivity. Okay. Now disadvantage is that these systems are actually complex. Why do we say that it's complex? Because we have an additional feedback system and other correction related circuitry in the system, so that makes the system complex compared to open loop systems, right? Hence there are more number of components or additional systems associated with the closed loop system. This kind of systems will be costly. So second disadvantage is that the system is costly. Closed loop control systems are costly. Then in closed loop control system we have a feedback, so that feedback can lead to oscillatory response. That is another disadvantage of these systems. Okay, so feedback may lead to oscillatory response. Also feedback reduces the overall gain of the system. So normally we go for a negative feedback, and this kind of negative feedback has the effect of reducing the overall gain of the system. So that is another disadvantage. And finally, as I told, stability is actually a major problem in closed loop control systems, but to some extent we can ensure that the system is stable, but we have to adjust the sensitivity of the system. Okay, so this is important actually. Different types of control systems. Basically we have two classifications: open loop control system and closed loop control system. Open loop control system is also known as non-feedback control system, and closed loop control systems are control systems having feedback.